ऐसी दोस्त हो रहा था 3 बजे से कैसा कैसे जा पाएंगे हम मैं गया भी तो था लेट में 1:30 এই অ্যাসাইনমেন্ট বাড়ি বৃষ্টি হচ্ছে না গরম বৃষ্টি হচ্ছে আমি না বেরিয়েছিলাম আমার না আসতে পারছিলাম না।
তোমাদের ওখানে ছাতা নেই বাড়িতে?
আমি আমি তো ইয়েতে গেছিলাম না ওই যেখানে জন্মাষ্টমীর খাবার ভোগ খাওয়া ছিল ওখানে তো ওখান থেকে আসতে পারছিলাম না। এটা করেছে।
I will start the class in next 5 minutes. We'll wait for some more students to join. Otherwise, I will start the class in 5 minutes. Okay. So welcome to the live interactive session of the course Natural Gas Engineering. Today I am going to discuss some sample problems based on assignment number 5. My name is Ananya Mandal. I am PA for this course. So let's discuss. So the first question is a vertical separator under the following conditions of the oil flow rate of 3800 STV per day with gas oil ratio of 400 SCF by STV and operating pressure of 80 psi. The gas flow rate is equal to, and options are A 3.5, option B 1.52, option C 5.7, and option D 7.1 SCFD. So, as we know, gas oil ratio is the ratio of the volume of gas produced in standard cubic feet in a reservoir to the volume of oil produced in standard tank barrel at standard temperature and pressure. So, here the ratio gives us that of the volume of gas to that volume of oil. But here they are talking in terms of volume flow rate. So, it will be the same thing. Volume, the ratio of volume and ratio of volume flow rate will be the same as the time constant will be similar in above and below and it will cancel out. So that's why similar to the ratio of a volume, we can also equate the gas to oil ratio equal to the volume flow rate. So here gas to oil ratio will be equal to the volume flow rate of the gas divided by the volume flow rate of that of oil. So in the question we have they have already given the oil flow rate and we have to find out the gas flow rate with the known gas oil ratio. So that will be gas oil ratio will be equal to volume flow rate of gas divided by volume flow rate of liquid of oil. Oil is known to us, so volume flow rate of oil will get multiplied to the gas to oil ratio, and from that we will find out the gas flow rate. So that's what done here. We multiplied the gas oil ratio with the oil flow rate, and from that we found out the gas flow rate, which comes out at 1.52 mm SCFP. Next question is a common question for question number 2 and 3, that answer the questions 2 and 3 from the data given below. A gas is flowing at a rate of 12 mm SCF per day through a separator of diameter 2 feet. A condensate of API gravity is 65 degree API is flowing at a rate of 28 VBL per mm SCF. The operating condition is 850 psig and 80 degree Fahrenheit. Considering gas compressibility factor to be 0.7, K equal to 0.21 and density of gas to be 0.035 pound per feet cube and density of liquid is 62.3 lb per feet cube. So the question number 2 is, what will be the superficial gas velocity based on total cross section area? Options are A 8.85 feet per second, option B 7.23 feet per second, option C 2.76 feet per second, or option D 5.54 feet per second. So we know the empirical equations which are proposed by Souders-Brown talks about the gas capacity of oil gas separators. So the equation to find the final gas capacity, we need to find the velocity, and velocity equation is equal to K into under root density of the oil minus density of the gas divided by density of the gas. So it is given to us the temperature, the pressure, diameter of the separator, density of the oil, liquid, and density of gas. Also, we know the compressibility factor Z and K value equal to 0.21. So, all these values are given to us. From that, we need the density of liquid and gas and the value of K to find out the superficial gas velocity. So, this is the equation to find out the superficial gas velocity. This is equal to K into under root density of liquid minus density of gas divided by density of gas. So the density terms are known to us and also K value is given 0.21. We will put these values here and from that we will get the superficial gas velocity, which is equal to 8.85 feet per second, which is option A. Now, question number 3 is related to the last question where they are asking the gas capacity at standard condition for a vertical separator. So as we discussed here, first we need the velocity and then this velocity multiplied by the cross section area will give us the capacity of the gas. So here we have to find the gas capacity. So the equation of gas capacity can be written as this, which is the A cross section area multiplied by the velocity at standard temperature, standard conditions. So putting the values in this equation, as we already know the value of K and densities, the temperature and the value of Z, which is given as 0.7. The diameter are also given, that is 2 feet. So when we'll put all these values, when directly we can find out the gas capacity value, which comes out as 191 mm SCFD. That is option B. Okay, any doubts?
No, ma'am.
Okay. So have you tried the questions of this assignment? Assignment number 5?
I have just watched the recordings 10 to 15 minutes ago.
Okay. Okay, then we will. I hope the questions that I will discuss will be helpful for solving the assignments of assignment 5,
Yeah. Yes,
because
ma'am.
the topics which I am taking, the same similar questions are there in the assignment 5.
Okay.
So the next question is question number 4, that is match the following separator components with their functions. So the separator components are the centrifugal inlet device, mist engagement section and mist extractor, and that we have to match with their functions. Uh, Okay, so these are the different separator components and we have to match it with the function. So as already taught in class, the function of different separator components such as centrifugal inlet device. So it is a primary separation of the liquid and gas occurs in the centrifugal inlet device. Second is the large settling section of sufficient height or length, which is known as the disengagement section, which allow the liquid droplets to settle out of the gas stream and adequate surge room for slugs of liquid. And finally, the mist extractor or eliminator near the gas outlet is to coalesce the small particles of liquid or make it amalgamate. So these are the functions of the different separator components. So we have to match the components with their functions. As I already discussed, we can see for centrifugal inlet device, it is the primary separation of liquid and gas. So option C will be connected to the first one. Second is disengagement section. So it allows the liquid droplets to settle out of gas stream and gives an adequate surge room for slugs of liquid. So option A is the one matching the function of the separator component, and finally the mist extractor. So it will be to coalesce the small particles of liquid. So from this match the following, we can see option A is the correct one. The next question is select the correct statement. So statements are option A. While designing a separator, length difference in vertical separator and height difference in horizontal separators are not considered. Option B. Vertical separators are designed to handle fluid with a high gas to oil ratio compared to horizontal separators. Option C. The gas liquid interface is greater in the horizontal separator than in the vertical separator. And option D. Spherical separators have very high surge space and liquid settling sections. So yes, can you tell me what will be the answer for this question? Which of them is the
Option
correct
C.
statement? Option C.
Option C is the correct.
So the gas liquid interface is greater in the horizontal separator than in the vertical separator. So yeah, your answer is the correct one. So let's discuss the different separators. So the first statement they're talking about is an empirical statement. So the actual empirical statement states that the height difference in vertical separators and length difference in horizontal separators are not considered. Whereas the first statement they are saying that the length difference in vertical and height difference in horizontal separators are not considered, which is opposite to the empirical statement, hence it is not the correct one. Next is that vertical separators are designed to handle fluid with high gas to oil ratio compared to horizontal separators. But the vertical separators are actually used when there is an intermediate gas oil ratio. And also other conditions are that it has large sludge of liquid and it occupies less area but costly fabrication. Then the third statement is that the gas liquid interface is greater in the horizontal separator than in the vertical separator, which is the correct statement. As horizontal separators are widely used for high gas oil ratio well stream, much greater gas liquid interface is there. That's why and horizontal double tube separator, low cost and high liquid capacity. So these are the different properties of a horizontal separator. So in that you can see it has said that it gives a much greater interface for the gas and liquid. Hence option C is the correct one. Also about spherical separators have very high surge space and liquid settling sections, but the spherical separators have, it is said that it has very limited surface space and liquid settling section. Also, it is an inexpensive and compact separation arrangement, and the liquid level control in this type of separator is critical. So these are the different properties of the different types of separators. From that, we can solve, we can tell which is the correct state. So the next question, question number 6, is that a vendor mistakenly fabricated a separating column such that the liquid capacity is reduced by 20% of the original value. How much difference in liquid settling volume can be expected if the retention time is constant? So the options are A, decreased by 20%, option B, increased by 20%, option C, decreased by 400%, or option D, decreased by 10%. So here they are talking about a relation between liquid capacity and the liquid settling volume and the retention time. So there is an equation which is relating all of that. So the liquid capacity equation is equal to 1440 into the volume of the liquid settling volume divided by the retention time. So this is the equation for the liquid capacity. So here you can see the liquid capacity is directly proportional to the liquid settling volume and inversely proportional to the retention time. Now, it is said that the vendor mistakenly fabricated a separating column such that liquid capacity is reduced by 20% of the original value. So, if the liquid capacity is decreased by 20%, then it is directly proportional to the liquid settling volume. So, this will also decrease and retention time will increase, and it is inversely proportional. So when we will directly proportionate the QL to the VL, we can see if QL is 20% reduced, then in VL also there will be a 20% decrease. So option A is the correct answer. Next is that select a suitable condition which will increase the liquid recovered in the separator theoretically. Options are A, increase in operating pressure or operating temperature. Option B, increase in operating pressure or decrease in operating temperature. Option C, decrease in operating pressure or operating temperature. And option D, decrease in operating pressure or increase in operating temperature. So which one will be the answer for this question?
Decreasing the operating temperature, and which we will use, I think, choke. choke is used to decrease temperature and while increase the pressure, operating pressure. That will be the answer according to me.
So which of the options?
Wait. Option B.
Option B. Okay, good. Option B is the correct answer. So uh, the conditions for to it, as you said, the pressure will be reduced by choke, and if there is a low temperature, a low operating temperature, at that time we get more liquid is recovered. So option B is the correct one, by increasing an operating pressure or decreasing the operating temperature. So next question number 8 to 10. The following data is given. The composition and other details of a well streamed fluid is given below. The operating pressure and temperature of the separator are 600 psi and 200 Fahrenheit respectively. To perform the flash calculation, and answer can be approximated by the 4 decimal points. So the composition and the critical temperature, pressure and boiling temperature, these all values are given to us. Now here we have to perform the flash calculation, and from that we have to find out the value of NVNL, the apparent molecular weight of the liquid phase and the apparent molecular weight of the vapor phase. So these three questions are related to this data. Now for flash calculation, the first thing we have to do is, if the values of Ki are known, then the number of mole of fluid in the vapor phase can be estimated. Then Xi and Yi can be calculated. From that, the apparent molecular weights of liquid phase and vapor phase can be calculated. So these are the steps for the flash calculation, but we only need to find out the number of moles of vapor, liquid, and the apparent molecular weight of liquid and vapor phase. So these are the given data: the operating temperature of separator, operating pressure of separator, critical pressure of all the components, critical temperatures, boiling point of all components, the molecular weight of all the components, well stream composition of all components. So first step is to calculate the equilibrium ratio. So equilibrium ratio Ki is equal to Yi by Xi, and also empirically Ki can be calculated according to standing by 1 by P 10 to the power A plus C Fi. So this constants A and C, the equation is given with respect to the pressure. So pressure is already known to us, that is operating pressure is 600 psi and temperature is 200 Fahrenheit. So here A and C can be calculated, Fi can be calculated. This Ki has to be calculated for all the components that are present in this uh, in this stream. So this all these components, for all the components we have to find out the Ki value, and all of them we already know the boiling temperature, the critical temperature, and the critical pressure. So from that we will find out the Ki values. Next step is solving the following equation to get the value of Nv and Nl. So total number of moles, if we say total, if we consider the total number of moles is equal to 0, so from equal to 1, from that we can get the mole fraction more easily. So the number of moles for in vapor phase and number of moles in liquid phase will be equal to 1. So according to that, we can use this summation equation, find out the value of Nv, that is the number of moles in the vapor phase. So already sir has described the steps how we reach this equation. So when we will be doing the goal seek, so at that time we have to find the equate this value, put these values and find this, solve this equation and equate it to equal to 0. So when this value will be reached, from that we can find out the value of NV and NL. So next is the calculation of XI. So XI is calculated using the following formula, and similarly YI has to be calculated, where Ki, as we already know the values of Ki is equal to Xi by Yi, but if we have to find the value of Xi, Yi is not known to us. So for finding, for equating the value of Yi, this whole equation is formed. So similarly, when Xi is not known to us, to find out Yi, this whole equation is formed. So the derivation of all this, how these equations came, are already discussed in the class. Next step is calculation of apparent molecular weight of liquid phase and vapor phase. So the equation for apparent molecular weight are this. For that we need the mole fraction, and molecular weight of each component is already known to us. So solving all these steps, this will be the final Excel sheet. This is how it will look. So the components, their critical pressure, temperature, boiling temperature, Zi is given to us already. From that we have to find out the values of coefficient A and C. You can directly put the equation in the Excel, and from that it will find out the value of A, C and Bi, Fi. From that you will find out the value of Ki. Now putting the value of Ki and Zi in this equation, you have to goal seek it equal to 0. So this is the main step, where you have to try to equate this whole values equal to 0, and from that you will find out the value of NV. Because NV is already known to us here, so we have to, this goal seek is like an iteration. So they have to put different values of NV here such that this whole summation will be equal to 0, and the value at which this, at that NV value, when this will be equal to 0, we will find the NV value. So it is a type of iteration. So once NV value is known, 1 minus NV, you will get the value of NL, the number of moles of liquid. Now, as discussed the steps, we can put the equations and find the value of the Xi, Yi. The molecular weight of individual component already known to us. From that, we can find out the apparent molecular weight of both liquid and gas phase. So by doing all these calculations, the final values we got: NV equal to 0.9326, NL 0.0674, the apparent molecular weight of liquid phase equal to 56.5688, and the apparent molecular weight of vapor phase equal to 22.7884. So these are the values that were asked in the question. So question number 8, option A is the correct one. Question number 9, option B, and question number 10, option D. Any doubts in this question?
Madam, this is an iterative solution. So, is there any possibility we have a shortcut trick for it to remember all
No.
that thing?
Uh,
Or if, let us say, in theoretical exam, if this type of questions arise, then how to solve that? Because at that time we are not allowed to use PC or Excel sheet at that time.
See, I think this is a very time-consuming question. So directly for you to solving these type of question won't come. This is for you to understand and for these assignments, because you have the sources. In the final exam, what I think, these type of questions where you will need your Excel sheet and all won't be coming. But I can't like guarantee you for that. I think sir takes extra classes and he comes for live sessions, so it will be better if you ask him about this. So how like the final exam question will be, because sir will be able to answer it better. Also, there is a discussion forum where you can post this question that uh, will this type of questions be coming in the final exam or not? Because there is no other shortcut. Sir also taught us in like Excel how you have to do it in the Excel, and most of the calculations are done in Excel only. So I don't know. if it will come in the final exam. So it's better you put it in a discussion. So sir will be able to answer it. Okay.
Okay, that was the only doubt. I have no doubt regarding this amazing lecture. I understood all of that. Thank you very much.
Welcome. Okay. So okay then we can end the class here.
Okay.
Okay. So now try to solve the assignment questions that are
Yes.
uh, that you have to submit tomorrow. I think so. It's better you finish it.
In that, we have to use Excel sheet.
Yeah, you have to do. Like, I think this type of question is also there on flash calculation.
Okay.
Okay, then. Thank you.
Welcome. Ma'am, can I leave?
Hi, you can leave. Hi, you can leave now. The class, it is over, but I will wait for other students to come if they join late also. So you can leave.
Okay, ma'am. Have a great day.
Thank you. Same to you.